Howdy, my name is Rosie Morey, and I am an academic peer mentor here at Texas A&M University. Today we are going to be talking about mastering general chemistry. General chemistry is one of the more rigorous introductory courses at college, but it is essential that you master the skills that you learn here because they will be carried on into different STEM courses such as OChem and physics and other different science courses that you will take. So without further ado, we will begin the video. If you note here that we are going to be dividing this video into essential skills, please note that they are not tips, they are not tricks, they are skills. They require a lot of practicing and a lot of developing in order to master this course. And it is important that we pay attention to the skills that we learn because they will really help us in understanding how to solve any chemical or chemistry related formula or equation that we get. So it is important to understand that these are skills and that there is no shortcuts to chemistry. It all requires a lot of work and effort. So they are going to be translating math, understanding units, and be on a practice lookout. The first one is being able to translate mathematical formulas into conceptual language. We are going to start out with a formula that a lot of y'all may have seen if y'all have taken the first few weeks of Gen Chem, and that is E equals to 8C over lambda. Now, the first step in understanding any formula is to know what each of the terms mean. If you want to test yourself, you can pause the video and write them down or keep them in memory. But I'm going to go ahead and name them out for you. So what does each of these terms mean? E is the energy of particle in joules. H is the Planck's constant, which is 6.626 times 10 to the negative 34 joules second. C is the speed of light at 3.3 times 10 to the 8th meters per second. And lambda is in wavelength in meters. A lot of times it is given in nanometers or micrometers. It is essential that you convert it back into meters, but that is something that we will discuss later. So how can we put this in words? If we look at the formula closely, we will notice that it resembles another formula. If we take H and C, we notice that they are both constants, so they will remain the same regardless of whichever situation you're in. And the only value that will be changing is lambda, which is wavelength. So we notice that we can replace 8C with K, and then it becomes E equals K over lambda. That equals a proportionality that you may have learned in high school. Can you guess which proportionality it is? If you guessed inverse proportionality, then you are correct. E and lambda are inversely proportional to one another. So a good way we can put this into words is the energy of a particle is inversely related to its wavelength, with the constant being Planck's constant times the speed of light. So that basically means that if the energy of the particle goes down, then lambda or the wavelength will go up and vice versa. So in that way, you can understand the concept of how energy and wavelength are related to one another from the formula. So this is a very essential skill that you will see again and again in general chemistry and in other courses, other chemistry courses, and that you will have to be able to convert such information given to you in a formula and be able to convert it back into English or conceptual language. So this is a practice problem. On a test, a question asks for the number of atoms, which will not be the correct answer. I'll pause for a second. If you answered B, then that is the correct answer. Why is that? So the skill here is translating numerical information into concepts. So we know from conceptual knowledge that atoms is the smallest unit in any substance. It cannot be further divided, so it cannot be less than 1. If we look at B, then it is 3.21 times 10 to the negative 19th, which is a negative number. Which is a decimal. So in that sense, it cannot be the number of atoms because atoms can never be less than 1. Now one may wonder why it's not C, because C is also times 10 raised to a negative number. But if we note carefully, it is only 10 raised to the negative 1. And that means that we will move the decimal place only one time. That will mean that it is 8.793 atoms um, is what the answer equals to. And it is still more than one atom. We might have to round that down to 8 atoms, but it is still more than one atom and it can be a valid answer. The next skill that we are going to talk about is being able to mathematically come to the right units. The method I like to use for this is called the train track method. So here we will be changing 1247873 centimeters into kilometers. The first thing I like to do is draw out my train tracks. You can draw out one or two at the beginning and then draw as many as you need later on for depending on how many conversion factors you have. You put your given unit in the first track, and then you just add your conversion factors. So 100 centimeters equals 1 meter, 1,000 meters equals 1 kilometer, so on and so forth. If you need to go further, and then you can go ahead and cancel out everything that appears once above and once at the bottom. So here I can cancel out centimeters and meters because they appear twice, once above and once below. uh, you want to make sure that you are left with the unit that you want. So here we are looking for kilometers. So the end unit that we have is kilometers and everything else gets canceled out. You multiply everything on the top and divide everything on the bottom. So that is 124,873 divided by 100 and then again divided by 1,000, which would give you 1.24 kilometers. Again, draw as many tracks as you need, but and then you can draw a couple of tracks and then draw as many as you need, and then make sure that all the units are canceled till the only one is remaining is the one that you require. And then finally, remember that if the units don't cancel out, it is not the right answer. So if you end up with units that do not resemble the unit that you've been asked for, that means that it's not the right answer and you have to go back to your method and try again. So this is a very good way to check your answers, and that is why I love this method. So definitely try and use this method. So another practice problem. Sodium dissolves in water to form sodium ions and a couple of other products. If we start out with 3 grams of sodium, what would the molarity be in 0.5 liters of water? So we go ahead and, sorry, a good practice to do while solving these sums is to know what units you want to end with. So molarity is going to have molar as its units. And if you're paying attention, then it also means that molar equals moles per liter. So that is the unit that we are going to have to end up with. We're going to go ahead and draw our train tracks, and then we are going to draw our given unit in the first track. Then we can go and access our periodic table and note that 22.99 grams equals 1 mole. 22.99 grams of sodium equals 1 mole. That will not be universal across all elements. So finally, we've achieved 1 mole in the numerator. That is what we wanted in the numerator. So we can go ahead and divide in the denominator and just put our liters in there. We can go ahead and cancel out the units that do cancel out, and we realize that we end up with moles per liter, which is what we wanted. We multiply everything on top, divide by everything on bottom, and we end up with 0.216 molar. So that is our answer. The final skill that we are going to be looking at is looking at appropriate resources and practice materials. These are 2 skills that we discussed. These are math-based skills that you should have had a good grasp on before walking into Gen Chem, but there are a lot of other skills that you are going to have to learn throughout your Gen Chem journey. So knowing what those skills are and trying to find practice material to practice those skills is very important. There are hundreds of different resources that you can use, and we are going to go through some of them. The first one is going to be the textbook. Your professor uses your textbook for making their lesson plans and making their exams. So this is always going to be a good thing to go back to practice. If you are not the type of person to read the textbook for reviewing, that is fine. but I would often advise students to go back to the back of the chapter and to go over some practice problems so that you understand how to work the formulas into word problems. The second one is homework and other practice material that has been provided by your instructor. This can be homework, practice tests, practice problems, discussion questions, anything that your instructor has provided is a gold mine for material. If you're a couple of days before the exam, I would go ahead and practice those as much as I can because you do really want to practice the skills that you have learned in class. The third one is the Academic Success Center at TAMU. They have a bunch of resources, and we're going to go over two of them. One of them is that they provide tutoring services. They provide tutoring services at 6 locations, including Evans Library, Hullabaloo, and the Commons. So I would definitely pop in if you need some specific help. They also have a Zoom session. So if you're attending classes remotely, I would definitely try and look at their tutoring services or go to their website and try to zoom in from there. The second one is the SI leaders. So the SI sessions that are organized by your class are from the ASC. Uh, your SI leaders, I would try to go to as many sessions as they can and attend their sessions. If you cannot go to their sessions, I would definitely recommend talking to your SI leader and getting access to their website. Their website has a lot of the materials that they use during their sessions and another bunch of practice problems. So I would definitely try and get in contact with your SI leader for that. The last one is online videos. I try not to recommend these to students because they are not TAMU specific. They're sort of generic for every Gen Chem student. But if you are stuck on a very specific concept or problem, then I would definitely recommend trying to go there if you're short on time. Just put the concept into the search bar in YouTube and a bunch of videos should show up explaining the concept. A couple of good websites that I like are Khan Academy. He has a really good series on Gen Chem and AP Chemistry. The organic chemistry guy, he not only just does organic chemistry, but he also does physics and calculus and a lot of other different subjects, including Gen Chem. And then there's Crash Course by Hank Green. I would not go to Crash Course for formulas or equations or very specific knowledge, but if you want a big picture or conceptual knowledge of chemistry, then I would definitely check out Crash Course. And that is it for this video. Again, we are the Academic Peer Mentor Program. We are located at Hullabaloo 125 at Commons 102, and we have office hours from Sunday to Thursday, 2 p.m. to 10 p.m. If you felt like this video was not very specific to what you are facing in Gen Chem, or if you are going through a lot of trouble in a different class, I would definitely sign up for a mentorship session or an academic checkup. Um, Academic checkups are where you can learn study skills and study habits from a mentor who is either part of your major or has taken the class before, and they can really help you and guide you through the difficult coursework that you're going through. So if you're having trouble in any of your classes, I would check the link in the description box below to sign up for an academic checkup with us. Besides that, if you want to subscribe to our YouTube channel or follow us on any of our social media, that is also linked in the description below. And with that, that ends this video. Thanks and gigum.